Swayam Prabha. Digital India. Educated India.
Hello everyone. Today we begin our discussions related to the course ESE 201 Introduction to Electronics. Well, if we look at a modern world, we find that it has been and is being rapidly transformed by electronics. It's not just the electronics products that we are well familiar with, almost like pure electronics products like the cell phone or the laptop or the TV. But if we examine almost any product around us, let's say a washing machine, you find that electronics is embedded within it. You examine an automobile, you find electronics is there. Aeroplanes, you find there's a huge usage of electronics there as well. Satellites, a chemical plant, and you find a medical diagnostic equipment. You find that in each one of these products, electronics is embedded within them and is playing a very important role. And if you look at each one of these products, actually they represent a solution to a problem. And therefore what we find is that electronics is being used in a wide variety of situations to solve problems. And the goal of this particular course is to enable you to learn how electronics enables use of electricity to solve problems. And there are several things that you learn as part of this course, and the lessons are more general in nature. And in fact, in general, you will learn how in engineering we solve problems. So many of the approaches that we will develop here with respect to electronics can be applicable in a more general manner as well. Well, so the question before us is why has electronics revolutionized our lives? If we examine 20th century, we find that almost all aspects of our life was impacted by electronics. And even in the 21st century, we find that the electronics is continuing to play a very important role. And as we said, that each one of these product represents a solution to a problem. And so electronics is being used to solve problems in a wide variety of situations in almost all aspects of our life. So the question before us is, what has brought about this electronics revolution? What is the source of such a large impact of electronics in our lives? Well, the question can be answered will be evident to you through these three statements here. First thing is obvious that every action requires energy. No matter what we are thinking of doing, whichever problem we are trying to solve, it would require an energy in some form. So that's a self-evident statement. Every action requires energy. The second one is electricity is one of the most useful forms of energy. Well, in fact, in an indirect way, our direct contact with electricity is often painful. We get a shock. But electricity has several useful properties. It's easy to generate, easy to transport over long distances. And the other thing is, even though electricity may not be directly useful to us, this third part is important. It can be easily converted into other forms of energy. For example, you may be interested in heat or light or a mechanical motion. Well, electricity can be converted to each one of them. You can use an electricity to generate heat or light or motion. And so that's a very useful property. It can be easily converted. And the other thing is easy to generate and easy to transport. Well, if you think about heat, for example, it's not so easy to generate. For example, you may take wood and light a fire and generate a heat, but it's not very convenient and it results in a lot of pollution also, we know. With the help of electricity, you're all familiar that using a resistive element, if you pass current through it, the heat is very readily generated. The other aspect is, suppose you want to transport heat thousands of kilometers away. It's just impossible. While here, electricity, for example, electricity may be generated in a power plant which is located 1,000 kilometers away, and we are able to transport it to your homes. So it's relatively, one is not saying it's very easy, but compared to other forms of energy, it's relatively easier to transport and generate electricity, and it can be easily converted into other forms of energy. So that makes electricity as a very useful form of energy. The third important point is, very important point is, that as a form of energy, we can control electricity precisely. We have a very, very precise control over electricity, the kind of control that we don't have over other forms of energy. So now, just imagine that you have a form of energy which is easily available and you can make it do whatever you wish. Why are we saying you can make it do whatever you wish? Well, because, as I said, you can precisely control it. Electronics actually provides us the ability to control electricity. So we said that to do anything requires energy, and electricity is a very useful form of energy, and we are saying you can make it do whatever you wish. Well, then the only limit is your imagination. And then it's little wonder that control of electricity ushered in the electronics revolution. Okay, so the source of the impact of electronics is that it's a form of energy which is relatively easily available. You can transport it, you can convert it into other forms of energy, and you can precisely control it, which means that you can do a lot with electronics. So let's look at a few situations. For example, we said look at all these areas where electronics is having an impact, and take the automobile for an example. Well, if I take an automobile for an example, there's a problem with the car that in the case of rain or snow, or when you're turning sharply, the car may skid. And the reasons for the car skidding are that the wheels are moving at different speeds. So to solve that particular problem, one has developed what is called an anti-lock braking system. And so the way the anti-lock braking system works is that we use sensors here to pick up the speed of each one of those wheels. And then we have an electronic system which, depending on the speed of the different wheels, what it does is it sends a signal to a pump, so hydraulic pump, which applies a brake to the wheel here. So whichever wheel, let's say, is rotating faster, the electronic pump would, more pressure would be applied to the brake, and the speed would be decreased. So thereby you could equalize the speeds of the different wheels that you see over here, and you achieve a much better performance. And a anti-lock braking system, for example, is a common feature in many of the automobiles now. So if you look at how electronics is solving a problem here, so car is a, let's say, before electronics, car used to be a pure mechanical system, and electronics is being now used to enhance the properties or the performance of the car here. So a pure mechanical system, and what you do is you add an electronic system to it. And by adding an electronic system to it, together the car with an electronics embedded within it becomes a much better system here. And so we can look at several other examples. In this case, for example, we see that the electrical system is helping in controlling the speeds of the speed of rotation of different wheels that you see here. Well, let's look at a communication problem. Suppose I was standing in L20 and addressing a large class, and I want my voice to reach to the farthest corner of the room. And so the environment in which I'm working, let's say this is the classroom in which one is interested in, and my interest is in the audio signal. I want my speech to reach to the students sitting in the last row. So my interest is in the audio signal, and well, in the absence of any electronics, all that I could do was shout at the highest volume that I could, or I could use a megaphone that you see over here to allow sound to spread over a larger area. But it would depend still on my volume to I have to rely for the sound to reach here. Now we can solve this particular problem through electronics. For example, my interest is in audio signal. My interest is not in electricity. My interest is in audio signal. So all of you know what we can do is we can add an electrical system to solve this particular problem. What is the problem? I want my voice to reach to the farthest corner of the room. So what we can do is we can take this audio signal, use a microphone to transform it into an electrical signal. So the microphone transforms an audio into an electrical signal, and we can now process the electrical signal. Now, we have said that in electronics it's much easier to work on variables than in other domains. So we can, for example, in this case, we could simply take the signal that we get from the microphone and we could amplify it, because our interest is in sound reaching all over the big lecture hall. So we could amplify it, and after amplification, we get another electrical signal, which is a much stronger electrical signal, and we can pass it to an actuator. So in this case is a loudspeaker. Actuator is something that converts electricity into some other forms of energy, right? So electrical signal is being transformed into an audio signal here, but this audio signal is much stronger, and therefore I become audible in the large lecture hall. So note that my interest is in audio signal, and but directly if I'm interested in audio signal, I stay in the audio domain, well, then I'm very limited in terms of how do I solve this problem of my sound reaching all over the lecture hall here. But if I transform this particular problem into an electrical problem, now I can take this electrical problem or electrical signal, amplify it. We can amplify signals in the electronic domain, and then we transform it and we come back to an amplified audio signal here. So thereby we are solving a communication problem here. And let's stick with the communication problem. Well, suppose there's a stadium and there's a live game going on, and you can't be at the stadium and you want to watch the game, and we all watch the game on our flat screen TVs that you see here. Well, how does that happen? Well, again, the principles are the same. We use a movie camera. So it's a sensor which will transform the video signal into an electrical signal here. And we have an electrical or an electronic system that you see over here, and we process the signal. We'll see some of this processing later on in the course. And we make the signal suitable so that it can be fed into an antenna and transmitted over longer distances. So this antenna transmits it, maybe to a satellite, and then you have your dish antenna that you see here. This antenna picks up the signal from the satellite here. It's a very weak signal. Well, what we do is we amplify it, we process it, and eventually make the signal, all this electrical signal processing will make it suitable so that the signal is finally ready to be displayed on the TV. Right? So your interest is not in electricity per se. Your interest is in watching a game and in your own homes, and electronics is enabling you to solve that particular problem. And we can cast this solution in the same format. This is the environment in which we are working on. This is the stadium, and we want to watch what is happening in the stadium from the comfort of our living room, right? So how do we solve it? Well, we use a sensor again to transform it into an electrical signal using a movie camera. And actuator, as I said, is something that converts an electrical signal into some other energy form which is of interest to us. In this case, the energy form is light, visual information. So the TV is a actuator which will convert electrical energy into an image here. And there are lots of things that we do in electronic signal processing, which includes the antennas, and there are amplifiers, then there are several other things that you see over here. All right, so we see that we have a problem in our environment in which we live, and we are solving that problem by transforming it into an electronics problem. Well, the electronics can be applied not just in the situations that we have just discussed. This is an example of a smart building where you can alter the shape of the building in response to, let's say, a weather condition or an earthquake, or for aesthetic reasons also. Well, these we are well familiar with. So a prosthetic limb, for example, you cannot imagine a modern prosthetic limb without electronics embedded within it. And sometimes the electricity is a part of the system. Our human body works on the principle of electrical signals, the nerves and the muscles and all that. And therefore, if we pick up those particular signals, as here in the ECG, the heart, if we pick up those signals here, that can be, and then use that to for diagnostic information. And so the electrical signal is directly of interest to us, and we can infer useful information from it. In other cases, we are using electricity to solve a problem. Well, so the idea is that you can use electronics to solve a wide variety of problems by whichever problem you're interested in. What we are suggesting is transform it. See, there may be an opportunity of transforming it into an electronics problem. And why should you transform it into an electronics problem? Because it's far easier. We can control electricity to a very precise extent, and the things that you can do with electricity, with an electrical form of energy, you can't do with other forms of energy. So because of this precise control, it makes sense to take whatever problem you're trying to solve and see whether it can be transformed into an electronics problem. And it's for that reason, because of this wide nature of its application, the electronics and the course that we are talking about is of interest not just to electrical engineers, but to every discipline. And we can, as we said, that the techniques that we use in electronics can be generalized to a wide variety of situations. So even this particular approach, we can generalize it to the following. Let's say whichever domain you're working on, you have a problem in that particular domain, right? And you're trying to solve that particular problem, and to obtain a solution is not that easy. Well, so you're working in some domain, and so what this particular approach is suggesting, that there may be another domain, let's say, where it may be easier to solve the problem. So what you do is you take your original problem, transform it into a new problem in domain 2. And why are we transforming it to domain 2? Because we think that domain 2 will allow the problem to be solved in an easier manner. So we take this problem, transform it into a new problem, and we solve it. And we are saying it's easier, it may be easier to solve it in this particular domain, so you obtain a solution. And then what you do is you transform it, some kind of an inverse transform, back into this particular domain, and so you obtain a solution. So instead of working in the same domain and trying to obtain a problem by any means, or it may be very difficult to obtain a problem in this particular domain 1, what we are saying is, if it may happen that you have another domain available, so you transform the problem into that particular domain, solve it, and then go back to your original domain here of interest here. This is what we are doing. We are using, for example, for us, the domain 2 is electronics. The domain 1, our environment could be, we may be interested in an audio problem, or we may be interested in a image problem, or we may be interested in, let's say, the wheels of the car turning or rotating at the same speed. We may be interested in some problem in domain 1, and it may not be easy to solve it here. So you transform it into domain 2. And for us in this particular course, what we are doing is, the domain 2, an easier domain, is the electrical domain here, or the electronics domain here. Okay, so it's a general problem solving approach which you could use to your advantage in many situations here. As an example, so this is our general problem solving approach that one is suggesting that could be applicable in many situations here. Problem 1, that's where the problem exists and you're finding it difficult to obtain a solution here. Domain 2 is a place where it may be easier to solve problems in this particular domain. So you take advantage of domain 2. Now this is something that you've been doing for a long time. For example, in your school days, you learned, for example, how to use mathematics to solve a problem. In fact, algebra, let's say, was a place, for example, where you use algebra to solve a problem. You know, imagine, I'm sure all of you would recall a problem like, let's say, there is a field that has to be cultivated, and let's say a person A can cultivate that field in 8 hours, but that person wants that field to be cultivated in a shorter period of time, so he hires person B and person C. Now person B is twice as efficient as him, which means he can complete the job in half the time, and person C, let's say, is half as efficient as him, so he would take twice the amount of time. So suppose A, B, C all work together, and the problem is in how many hours will they complete the work. Well, we've learned that problems like this, you can take that particular problem, you want to figure it out, how long will it take to cultivate the field if all A, B, C work together. So you have this particular problem of cultivating the field. So how do you solve it? Well, you transform it into an algebraic problem, and it's easy to solve that particular problem in the mathematics domain, and the solution that you obtain, you can come back and say, well, maybe it can be solved in, the whole field can be cultivated in 2 hours now, right? So it's a simple example of how algebra is used to solve problems. And in general, we find mathematics is used widely, as you may all be aware of, for solving problems. In fact, the backbone of mathematics, the backbone of engineering is mathematics. In all domains of engineering, you find that whatever problem you're trying to grapple with, the problem is transformed into a mathematical problem through a process of modeling. and you solve that problem as a mathematical problem, and then you transform it back into the solution that you obtain, back into, you project it into the domain that you're looking for. So a very general problem solving approach is, mathematics is very easy for us to, mathematics is a place we all know, easy to manipulate symbols and arrive at results here. And that's why we use it to our advantage. In this particular course, we are saying electronics is also a domain where you can solve problems readily. And so take advantage of electronics. Wherever look upon electronics as an opportunity to solve a wide variety of problems. Okay. So if we look at this electronic system, so we are saying we are going to use electronics to solve problems. So whichever problems that we are looking at in an environment, we'll use sensors to transform it into an electrical problem. And then after doing a lot of processing of the electronic signal, we'll transform it back using actuators into a signal or a quantity of interest in the environment. So what are the elements of the electronic system? Well, if you use sensors to transform your signals into an electrical signal, what you find is the signals are typically analog in nature. For example, in this case, let's say the sensor is a microphone, and this is an electrical signal that I obtained from a microphone here. And we call such a signal as an analog signal, meaning that if I look at the voltage, for an example, the voltage will be can take any value within a particular range. Let's say the range is -3 volt to +3 volt, and the voltage could take any value in that particular range here. And the signal is continuous in time and can take any value in a certain range, and we call such signals as a analog signal. And so what we do is, the signals that we obtain, for example, this is a ECG signal picked up again through sensors, and this is also what you find is an analog signal. So our electronic system, what it contains is at the front of the electronics you have analog signal processing. So you take this particular signal, it's a weak signal, you may amplify it. It may have noise embedded in it, so you filter out that particular noise. So there's an analog front end here, which processes this audio signal here. And then what we do is, often in modern electronic systems, we take this analog signal and we convert it to a digital signal. And digital signal, you're familiar with, works with binary values. The signal of interest is only whether the signal is high or low. And so we work with that, and it's much easier to manipulate signals and do things with it in the digital domain. So that's why what we do is, the signals are analog nature, we transform it into a digital signal here using an analog to digital converter. We do all sorts of processing in the digital domain, and then what we do is we use something called a digital to analog converter. So it converts the signal back to an analog signal here. We do some signal processing here. We may amplify the signal and convert it to other forms here, and we send the signal here back to an actuator to go back to the environment and generate a signal of interest here. All right, so in this case, for example, it was an audio signal. So we do all kinds of processing here, and we do all kinds of processing, analog processing, digital processing, and we convert it eventually into a audio signal with the right frequency components, and then we send this audio signal to a loudspeaker, and then we get an audio signal of interest here. So the electronic system that we are talking about includes these major parts that you see over here. There's an analog signal processing part here. There's a digital signal processing part here. And then there are what we call as data converters, analog to digital and digital to analog. So in this case, what you see here is even though our interest is in analog signals here and an analog signal here, we are converting into a digital signal. Why? Because it's much easier to work with signals in the digital domain. So the same principle that I talked about earlier. If something is easier in one domain, what you do is you take advantage of solving things in that particular domain. So even within the electronics domain, it's easier to solve problems in the digital when the signals are in the digital format. So therefore, even though I obtain a signal which is analog nature, continuous in time and continuous values within a range, we transform that problem into a digital problem, solve it here, and then we transform it back into an analog signal here. So these are A to D is what transforms analog into digital, and D to A what transforms the digital to an analog signal here. So if you're trying to understand an electronic system, these are the three major blocks of an electronic system: an analog signal processing front, a data converters, and digital signal processing. So let's come back to, so these are the elements of a digital system. So one of the developments that has happened over the years, we'll look at the reasons for it, is that this digital, so you would realize that what we are doing is, because of the convenience of solving or manipulating signals in the digital domain, this is where we do bulk of the work in electronics here, right? So the analog signal that we obtain, after solving a few issues here, we quickly convert it to a digital problem. We solve the digital problem here, and then once we are done with it, we convert it into an analog and we send it back into the environment here. So one of the things that has happened is that this digital system has evolved into a programmable digital system. Programmable, we are all familiar with microprocessors and computers here. So these digital systems that you're talking about, this is nothing but a kind of a computing platform, or a microprocessor or a computer. So it's programmable. So what has happened is, because electronics is being used to solve a wide variety of problems and to enable a wide community of people to solve problems using electronics, so what has happened is that people have developed what are called general purpose programmable hardware, so that everybody doesn't have to design electronics. So a general purpose hardware is available, which includes analog signal processing modules, data converters, and digital signal processors, and all those are there. And this is programmable. So what you can do is, whichever problem you're interested in, you can add a software. So you can add a software, and the software is what programs the digital hardware to do whatever you are looking for, right? So depending on the nature of the problem that you're trying to solve, what you have is, you use a sensor to convert into an electrical problem, and this general purpose programmable hardware will convert it eventually into a digital signal. And then you add a software to it, and the software will manipulate the digital signal according to the needs of your problem. And then once that is done, it's sent back to a standard D2A converter and analog signal processing, and you come back through an actuator depending on the problem, and you achieve the signal of your interest. You solve the problem in the environment that you are interested in. So what we find is, here we're talking about software as a solution. The whole thing, the whole electronics, is a general purpose programmable hardware that you can buy. The sensors is something also that you can buy, standard sensors, and actuators is also something that you can buy. So virtually anyone can solve a problem using electronics by writing a software. Right? So software has become a very, very common technique for solving problems, and that's because the electronics has evolved in the direction of programmable hardware here. All right, so we said that the goal of our course is to learn how electronics enables use electricity to solve problems, and this is the picture that we will keep in the mind here. This is how electronics enables you to solve problems. These are the elements of an electronic system, and this is a general methodology, transforming a problem into an electrical problem using an actuator to transform it back into the problem of interest here. So if you look at it, the major elements of this particular block that you see here is an analog signal processing and digital signal processing here. So the goal of this particular course is to enable you to learn how analog and digital circuits work. And you cannot just learn by passively listening to how things work. So in ESC 201, we will learn by analyzing and designing analog and digital circuits. So that's what we will be doing in order to understand how electronic systems work, right? And so these are the elements of the course here. Analog circuits block is one major block of this particular course here, where we'll be talking about semiconductors, diodes, and transistors, and amplifiers, and other analog circuits here. About 11 or 12 lectures will be devoted to analog circuits. The other part is the digital circuits. So another 1/3 of the course is devoted here to the digital circuits part here. And each one of them is a circuit, analog circuit or the digital circuit. So before we can begin our discussions and start analyzing and designing analog or digital circuits, what we need is certain tools for circuit analysis. So we'll spend some time here learning how to analyze circuits. So our course is going to proceed in this particular direction here. We'll start with tools for circuit analysis. We'll spend some time here. Then we'll go to analog circuits, and then we'll go to digital circuits here. Well, we'll rely mostly on these books to, if you want to learn more about any of these topics, then you can use these particular books. The first two are for general circuit analysis. The next four books are for analog circuits, and the last two books are for digital circuits. Well, we are all learning how to use an online mode for teaching, and these are how we plan to carry out evaluation for this particular course. But please note that these are very tentative. We don't know how things will work out. We'll have written midterm exams. Instead of a single exam, we may break it up into 2 or 3 smaller exams. We'll see how to do it in a convenient manner. The weightage also may change, but the tentative weightage is about 30%. Similarly, final exams are there. Tutorials are 10%, quizzes are 20%, and so we'll, so it's all new to us. We'll learn how to carry these things out, and the exams are important, but focus more on learning, and the exams will tell you how well you are learning. All right, so look upon them as a mirror to how much you've learned and where your deficiencies may be. Well, this is where my office is, but now this is an online mode, so we will not be able to use it. My telephone number here, but you can contact me over the email that you see over here. And so we have a discussion hour every week, and so please send in your queries well in advance, and we'll address it during the discussion hour, which is on Wednesday 6 to 7 p.m. So lecture notes, assignments, solutions, etc., they would all be available on the MOOKit platform that we're using for this course. And as I said, discussion is on Wednesday 6 to 7, tutorials are on Friday 6 to 7 p.m. here. The goal of discussion hour, we will be posting lecture notes in advance. So the goal of discussion hour is to clarify certain doubts related to posted lectures. As I said, we have a large class, so if you send in queries well in advance, we can use discussion hour to address those queries, and that would benefit everybody in the class there. Homework assignment sheets will be given every week. And please remember that simply listening to the lecture is not going to help you that much. For learning, it's important that you engage with the material in an active manner. The homework assignment is meant as an aid for that, so try to solve all the problems and prior to the tutorial, which is on Friday. And we'll post a few problems related to topics. If you want more problems, well, you can find it in the books that we have prescribed for you. You're not required to submit the homework solutions during the tutorial. So what would happen is the problems that are given as part of homework assignment, as usual, the solutions to those particular problems will be discussed. And also, you would be asked to solve a problem related to the homework assignment during the tutorials. So that would be done live. And so this is there, and more details, and as we learn more details regarding conduct of tutorials and discussions, so we'll work in another engineering principle is the iterative problem solving. You cannot solve problems at one attempt. So what you do is you try out something, and then during the trial you learn something, and then you modify your approach. So this is what we are going to do with this particular course also. So we're planning something, and as we go along, we learn, and we'll see how we can iterate and make things better. So let me end by showing you that this particular diagram, which tells us that why electronics has impacted our lives, and how you can take electronics as an opportunity to solve whatever problem you may be thinking of by basically whatever problem you're thinking of, transform it into an electronics problem. And we have a wide variety of techniques, a wide variety of tools to solve problems in the electronics domain. The kind of ability that we have to solve problems in the electronics domain, we don't have in other domains to that extent. All right, so this is the other diagram to keep in mind, that this is how electronics works with sensors and actuators, and there's analog signal processing, digital signal processing, and you can see the role of the software here. Because my hardware has become programmable, so you can add a custom software. Custom software meaning software according to the problem that you're trying to solve. So you can add a custom software, and this particular hardware will do what the software will command it to do, right? So the whole thing, then the whole electronics module will do things according to the software that you've added here, and thereby it will solve the problem that you're interested in. All right, so let's stop here. And please note that all the lectures are not going to be 1 hour lectures. Some may be shorter, some may be longer, and we'll try to have each lecture as a coherent topic. All right, okay, so let's stop here.